apologize beforehand because I am quite sick, and I was coughing my lungs out backstage. So if I break into a coughing fit, sorry. You can laugh at me, it's fine. Hopefully this never happens to you. But have some water, and that will hopefully be good. All right. Right now, the internet is in the middle of a revolution. Like most technology revolutions, it's deeply changing how things work, and it's hard to perceive in full what's happening, even when you're living in the middle of it. I'm going to share some stories from the front of this revolution. I'm going to be speaking mostly from my experience with blockchains and IPFS, the Interplanetary Files System. But before diving in, let me frame the story. The internet is humanity's most important technology. It's our shared nervous system, our shared brain. And everything that we humans do is starting to be put online. Well, most of our lives here in Silicon Valley are mostly over the internet now. We work together, we play together, we learn together, and so on. And this is extending throughout the world, reaching even very remote places in the world. New applications give us new superpowers. They're like software-granted magic, right? But these superpowers are defined by the properties of the internet and the properties of those applications. How fast they work, how accessible they are, how secure they are, and so on. All of these things determine and limit these superpowers. And they also determine how they fail, when they fail. Do you feel secure knowing that all of your digital life is running on all these applications on the web? Do you know how it functions in a catastrophic failure if part of the internet falls apart? So what's going now with this new revolution is that this is starting to get addressed. What we're moving to is a system with public verifiability, with other kinds of properties that are being baked in from things like blockchains and so on down the layers of the stack. And the best way to sum up this revolution is decentralization. Decentralization, moving from something that's centralized to something that's not. The services, applications, and data itself, computation, and so on, all of this stuff is being removed from some central entities and spread out through the network. And it's the right time to get involved. In fact, a lot of this thinking is not coming from Silicon Valley. It's coming from the rest of the world. And I think it's important that people here start getting involved in these technologies, because if you don't, the future may not be what you hoped for. So why decentralization, right? Like, what is the point? Centralization is effective. In a centralized network, there's a central point of coordination. It's simple, easy to manage and improve, but it's not very resilient. There is, of course, a central point of failure. And there's also a central point of control. That node in the center controls what the rest of the edges of the network can do. So it's in a way owned by that central node. The alternative is to go towards distributed networks or decentralized networks, and all of the nodes share the coordination responsibilities. This is much more difficult to make, but it yields a much more resilient system, as we can cut large numbers of links, bring down a bunch of nodes, and the parts of the network, even though separate, can still function. The failure semantics are significantly better, and nobody controls it. So Bitcoin is a perfect example of a decentralized service. It's not fully distributed, but it is decentralized. It's a global payment system, a secure transaction processor, an immutable public record timestamping service, as we heard, and the coordination work is being done by a bunch of computers put together, all the miners. No entity holds power over the rest of the network, and it's publicly verifiable. You don't have to trust that some entity is going to keep its word. Bitcoin's economic model incentivizes a huge number of people to work hard daily to keep the network running, to add more hashing power, to fix problems. These miners keep it going. But the worth of Bitcoin itself also incentivizes people to improve the network, to tell others about it, to broaden the reach. They are working for the network. They're sort of a workforce, a distributed workforce. Members of the network do what they think is most valuable for themselves and the network. Bitcoin aligns incentives, because if the Bitcoin price goes up, everyone benefits. So they're working together. If you think of Bitcoin as a company, it has thousands of employees, serves millions of people, moves billions of dollars, it's worth $10 billion in the currency alone, and who knows how much more as a platform. Since Bitcoin introduced the blockchain, there's been a series of important developments. New cryptocurrency networks and decentralized services are being created left and right to tackle various different kinds of challenges. I'll give you a pretty quick survey of the space. You already got one. But this will help you get a feel for the kinds of things that are coming, that are being built now and are being released. So of course, there's Ethereum, the second largest cryptocurrency network. It's like a global computer that runs decentralized programs. And these programs are called smart contracts. They're the closest thing we have to some sort of programmable law. And like Bitcoin, it's a decentralized blockchain. But it also features technologies that go beyond Bitcoin's reach and can do many other kinds of things. Ethereum has a whole host of applications riding on top of it, and they're just beginning to launch, so this will get pretty interesting. Auguring gnosis are built on top of Ethereum, and they're prediction markets where people can trade futures on the outcome of events. OpenBazaar is a decentralized free market on the internet. It uses Bitcoin and IPFS. People can buy and sell goods and services to each other. Users connect directly to each other without intermediaries. There's no one setting policy. It's just peer-to-peer. Steam and Akasha are decentralized social networks built with blockchains on IPFS. Steam has tens of thousands of users already, and people are using these things. Zcash, not yet live, is another decentralized cryptocurrency that offers private and selectively transparent transactions. It's like Bitcoin, but completely private digital cash. Worldwide private money is a new thing. It may be one of the most important financial innovations of this decade, maybe more. Filecoin, also not yet live, and I work on this, is a cryptocurrency incentivized storage network. It uses incentive structures similar to Bitcoin's and organizes a set of miners who work for the network, adding enormous amounts of disk storage. Think of them as Amazon S3 meets Bitcoin, the cloud cryptocurrency incentivized. These are just a few examples of the kinds of things people are building today. There are many others. You can look around. And this sample is the first wave. There will be many more iterations on this, and they'll build on each other. So it's very hard to predict what kinds of things will get built over the next couple of years. It's happening quite fast. And so when you have to kind of step back a little bit and think what's going on. And so when you squint a bit, and when you think about Web 1.0, it was about linking content together and bringing it online on top of the internet. And Web 2.0 was about linking programs to that content and allowing you to have dynamic applications on top of this nice platform. What's going on now is that we're using public verifiability. We're linking content and programs to each other directly without intermediaries. You won't have to trust those entities. And this is riding on a bunch of advances in cryptography, distributed systems, game theory, economics, networking, and so on. It's going to take what Bitcoin did to money and apply it to all kinds of services, all kinds of applications. And so decentralization adds a significant safety margin and resilience to these kinds of networks. They become more efficient in some ways. It changes the power dynamics. And it wrenches entrenched central controllers out. The other thing is that decentralization and fully distributed networks are the future. And it's undeniable because it's sort of mandated by the laws of physics. As our internet reaches areas that are distant, where latencies get high, or when you start thinking about going to other planets, then you can't rely on a central agent that's processing transactions. You'd have to wait, every round trip would be many minutes, and it would vary depending on where the planets are. So the internet will get completely decentralized and distributed. And it will help people on Earth as well to move in this direction, because to a data center that's operating at microsecond speed, somebody out in the edge of the network operating in seconds feels like a distant planet. So we built the Interplanetary Files System to solve these kinds of serious problems. We were deeply frustrated by a set of things that we saw were not getting better. And I'll describe a few of them so you get a feel for what motivates us. The web does not work offline, right? Or in networks that are disconnected. Suppose we're all working together on a shared document here, right now, with our computers. And the Wi-Fi network connecting us was just fine, but there was some problem outside of this room that prevented us from reaching whatever server was running this thing. the thing would break down. We wouldn't be able to work together. Even though our computers today are each a supercomputer of a few decades ago, and we're all connected just fine, the thing would cease to work. And this, I think, these days is unacceptable. And this gets particularly bad when you think about people in very poor networks, people whose access is intermittent or very constrained. And when you think about it, that's most of the developing world. This is quite outrageous, actually, because the internet is supposed to be a force for equality. It's supposed to equalize access to information and knowledge. And it's the people that need it most that get the least benefit from it. They are being blocked by these central entities that are forcing all of the connections to go to them. So there's other problems, right? There's problems of security and there's problems of resilience. And so think about how easy it would be to oppress a whole people when you can just cut a pipe, right? When you can just censor the entire thing. And all an attacker has to do is just find that one pipe and cut it off. And sometimes that attacker knows exactly where those pipes are. Sometimes it's your government. So this happened to Egypt in 2011. The government shut down the internet connection to the rest of the world. Local networks worked fine, but most applications required this access to central servers and just shut down. In the middle of an uprising, in such a crisis, overnight, people went from being connected to each other to suddenly not being connected to each other. People couldn't know if their loved ones were safe. They couldn't reach each other. This was like interfering with our nervous system, like interfering with our shared brain. And this attack exploited the brittleness of centralization. And that affects us all. Cryptographer Bruce Schneier recently wrote that someone is learning how to take down the internet. They're testing the security of the companies that run critical pieces of the internet. They're precisely calibrating attacks to determine exactly how well these companies can defend themselves and what it would require to take them down. I don't know about you, but that sounds terrifying. We're not ready. Almost none of the applications we use would work in a partitioned internet. And it doesn't take powerful state actors. Much weaker ones could do it. Or perhaps even natural disasters. They could cut off access to millions of people, and all of the logistics that coordinate the supply chain would fall apart. This would render the software superpowers that we've been working for the last few decades to build completely useless, and potentially overnight. There are other problems as well, but the last one I'll mention is that there's also a crisis of erased history. Every day, web servers change structure or shut down altogether, bringing down the content located there. Researchers estimate that the average lifespan of a web page is under 75 days. If you have a link to a web page, it may be inaccessible just 3 months later. Worse, vital data is going missing all the time. People's files, scientific papers, research data, critical records, it's a mess. This is the case even when people wish to back things up. The way things are, the act of backing something up or mirroring it means copying it elsewhere. It gets a different address. Copies of information on the web are not fungible. And this is quite weird to humans. Because in the physical world, multiple copies of a book are supposed to be the same. They're equivalent. That's not the case in the web. And so as I dug deeper into these problems, I got very frustrated and sad, and I realized that they're all caused by centralization in one small thing. And it's in the web, and specifically, it's the addressing. The core of the internet was designed to be fully distributed. It has no central point of failure and no central authority. TCP/IP, the protocols underlying it, are all inherently peer-to-peer. Any internet node can talk to each other. But the web, though it was designed with these kinds of principles in mind and has a lot of decentralization baked in, a problem snuck in. And it was meant to make things fast and efficient, and it made sense at the time. But the issue is that most links that you use to bind content together, and perhaps probably every link you've seen, is a URL. A URL has a flaw. It's based on location addressing. The domain name resolves to an IP address, the address of a specific server on one specific physical machine. So when you load the link, you are forced to fetch the file from that one server. It doesn't matter if you have it locally. It doesn't matter if you can find it in other computers right next to you. You have to fetch it from that one server. To frame it in the context of humans, think about it like a book. Imagine that we could only reference books by the physical location of one particular copy. not by title or author or ISBN, but by the physical location. So if someone told you to read a book, they'd say something like, hey, you should go read this amazing book that I just read. It's in the New York Public Library, Section 9, Bookcase 3, top shelf, first from the left. And you'd be like, all right, I will go there. And you travel all the way to New York. You get to the New York Public Library, Section 9, Bookcase 3, top of the shelf, and you find that someone moved it, and you don't find a book there. Great, like that's kind of ridiculous. Or what if the library is shut down that day, or maybe closed down permanently? Or what if this is just insanely inefficient and you don't want to make that trip? Or when you get there, you find out that it's the exact same book you've been carrying in your backpack all day. So this is ridiculous, right? Like, this is not how information is supposed to work. And the thing is that we lost something. When we moved from physical information that's printed to digital information, we lost some properties. When you get a piece of paper, you can hold it. You can store the information somewhere. You can back it up. You can pull it back out later. And you have control over it. That's not the case in the web. When you have a link, it's not yours. It's somebody else's. And they might move it. They might change it. They might shut it down. And so every independent copy of something on the web is its own entity. It's not copies of the same thing. You can't treat them the same. So we lost something there, and we need to get it back. I hope by now you feel the same kind of frustration that we felt, and you think about that this is silly, that things shouldn't work that way, that we know better, right? So there's good news. The solution is actually quite simple. We've known about it for decades, actually. It's not easy to deploy, and it's not easy to convince everyone to do this, but it is, in principle, quite simple. It's called content addressing, and it's the heart of IPFS. Content addressing derives a unique identifier for a piece of data. It's like a fingerprint, and these fingerprints are secure. They're cryptographic hashes. That's the same thing that secures Bitcoin and blockchains. It's actually what makes a blockchain a chain. So we put these fingerprints in the address of the file, instead of the physical location of the server. This way, when we're trying to load a file, we retrieve it from any place we can. If it's in your own computer, awesome, you don't have to go anywhere. If it's on the computers next to you, that's great. If it's, you can search the network with efficient routing algorithms and find the content you need and get it. And you can even tune it for privacy, where you're only requesting things from nodes that you trust. This is similar to what other peer-to-peer systems do, but on steroids, and built directly into the web. So IPFS decentralizes the web itself. It addresses information by what it is, not where it is. It separates what from where, so that data can flow through the network, so that it can be stored and served from anywhere, and so that web applications can work in local networks or disconnected networks. And so whether it's a chat room in an office that lost its uplink, or a scientific paper hosted in a variety of libraries, or Wikipedia in a remote village with students trying to learn, or a family's messenger during a crisis, IPFS strengthens our digital information, making it resilient to failures in the underlying internet, securing it cryptographically and giving it permanence through time. You, archivists, and others that care about something can copy it and store it and serve it back later. Let's stop losing vital information by accident or by neglect. That's the worst reason to lose something like a critical data set or a critical paper, and this has happened many times. So where are we? The network is live. It's addressing and moving billions of objects. The project has tremendous momentum. There's a huge open source project behind the whole thing, and hundreds of people work on it. Thousands of developers are building things on top of it, and businesses already rely on it as a key architectural component. So far, it's been primarily used by communities that care about security, public verifiability, repositories of documents, data, code, and so on, distributed applications. Blockchain applications are a particularly important use case because they can't quite rely on HTTP, so it's a perfect match. And funnily, it's actually been deployed in banks, so that's pretty cool. But now it's time to go towards more consumer-facing things, and we're ready for it. It's still early days. We're figuring how these things in the consumer area will work once they become completely distributed. But we built a chat app recently that we called Orbit. And it works just like any other popular chat app, but it has no central servers. It works entirely on decentralized principles in the peer-to-peer model that we want. Messages are cryptographically signed, so you know who wrote them. And it will be completely end-to-end encrypted. It's not yet, so don't use it like that, but it will be. When you're chatting next to someone, it feels right. Messages feel instantaneous, and sending even a large file to each other feels exactly as it should. It's going from my computer to the next. It's not going from my computer up the wires to some who knows where server in the cloud, and then all the way back down. So the interesting thing about Orbit is that the underlying libraries that we use to build it can be applied to any other kind of thing, to other kinds of social networks like Twitter or Facebook and so on. So all these things are coming. It'll take a while for them to start to get hold, but the pieces are there, and people are experimenting with them and building pretty interesting things. So the IPFS project is about fixing these kinds of fundamental problems and following through across layers and layers of software. It takes time to make your way through. It takes time to get the same level of performance that people have gotten through the web for decades and decades. But to succeed, we're going to need a lot of people to think about the web in this way, to think about the internet in this distributed way. This is why it is a call to a revolution, to rethink how we store our information, to think about distributing it, to think about public verifiability. And we succeed when the web just gets better for people, where people don't have to think about using something else, but developers will have to be involved. If you're wondering about the name, why Interplanetary File System, there's 3 reasons. 1, it's an homage to J.C.R. Licklider, who pioneered and kicked off the internet. He called it the intergalactic network. So the Interplanetary File System, it's the next step in that direction to realizing his vision of someday connecting the stars. 2, because designing protocols that work across vast distances like planets makes it possible for people around the Earth that are in distant areas far away from the data center to connect as easily and nicely as people in the nice, fast cities like this one. This is what we call the interplanetary principle. Design things for planets, planetary scale, and you'll do very well on Earth. And 3, we mean it. When we can and will use IPFS applications on Mars. We're actually committed to making all of these things work nicely, and we have a list of applications that need to be built and ready and working just fine well before SpaceX gets any person there. So when the pioneers make it, they'll be able to use the internet just as nicely as we do here. The one cool fact is that if they used Orbit over there, it would work just fine, and they would be able to chat like any other application today. So the next internet revolution is decentralizing services. It's decentralizing computation, and it's decentralizing data, how we reference things. It is making our networks more resilient. It is making them more capable and powerful. And it's protecting them. It's making sure that they fail correctly and they don't fail in a catastrophic manner where everything would just shut down. It involves blockchains, decentralized apps, cryptocurrency incentivized networks, and IPFS, the Interplanetary File System. Location addressing centralizes and makes the web brittle, insecure, and unusable in many circumstances. To overcome this, IPFS is upgrading the web to use content addressing, with cryptographic hashes as the main primitive. This will improve how we use digital information and will make it a bit more like printed information so that we can at least get that back. And I'll leave you with this. The revolution calls. It's not very loud, and you won't hear about it often, because in these days, revolutions happen on the wires, and they happen very quickly. These efforts and these kinds of networks affect you deeply. And you have to ask yourself, do you want a world that is centrally controlled? Do you want a web that works like that? Or do you want a decentralized free one? Because after all, it's completely up to you. Thank you.